Hello, hello, my dear students. This is the lecture about Corona. Corona, this is not COVID-19, but this is the Corona of the power system. Uh, you know, generally, Corona means you understood about the light that appears around the sun. जो सूर्य के सराउंडिंग में जो लाइट्स अपीयर होता है सूर्यास्त या सूर्योदय के दौरान उसको हम कोरोना बोलते हैं व्यवहार में. But in power system, this term is borrowed to describe the partial discharge that develop in the presence of high electric field. Partial discharge of what? Partial discharge of the dielectric medium. Generally, in case of transmission line, this is air. तो जो एयर का जो डिस्चार्ज पार्शियल या ब्रेकडाउन या आयोनाइजेशन कंडक्टर की सराउंड में ड्यू टू प्रेजेंस ऑफ हाई इलेक्ट्रिक फील्ड, इसी को हम क्या बोलते हैं? कोरोना. मतलब ड्यू टू हाई इलेक्ट्रिक फील्ड आयोनाइजेशन ऑफ द dielectric medium, ionization of the air around the conductor is known as corona. Right? Is that clear? Okay. Now there is a very derivation. We have to derive the formula in terms of voltage and displacements between the conductor and other factors. We will study about that in further page. Okay. One thing more, we have to know about this: the number of electrons increases when free electron normally present in the free space due to the radio and cosmic rays. कॉस्मिक किरणों की वजह से या रेडियो वेव की वजह से कुछ इलेक्ट्रॉन्स अवेलेबल होते हैं, and these electrons get accelerated due to the voltage of the power conductors. जैसे कि जानते हैं इलेक्ट्रिक फील्ड के प्रेजेंस में जो इलेक्ट्रॉन होता है एक्सेलरेशन इन द डायरेक्शन ऑफ फील्ड इलेक्ट्रॉन्स क्या होता है? एक्सेलरेट करता है. तो ये एक्सेलरेशन क्या करता है? दूसरे इलेक्ट्रॉन से कोलाइड विद द अदर मॉलिक्यूल्स ऑफ द एयर एंड दे डिसलॉज मींस विस्थापित इलेक्ट्रॉन्स फ्रॉम द मॉलिक्यूल्स से इलेक्ट्रॉन को विस्थापित करता है. एक तरह से जो मॉलिक्यूल्स या एटम की जो इलेक्ट्रॉन्स बाउंड होता है उस कोलिजन की वजह से due to high voltage there will be high electric field and this will cause the acceleration of the electron and this further cause the collision of the free electron due to the cosmic rays and radio wave in the space, and which this collision cause the dislodge or rupturing of the electron from the molecule of the conductor. Right? Is it clear? Okay. Now the discharge process depends on the polarity of the applied voltage. However, in the case of AC, polarity changes alternatively. In the case of DC, appearance of the corona is different. DC is constant, while AC is changed alternatively. A positive wire has more uniform bluish white glow and on negative polarity where reddish bits are formed. It's seen there that positive cycles produce white glow, bluish white glow, while the negative polarity of the wire produce reddish beads are formed around the conductor. Okay. Now, critical voltage. What is critical voltage? Critical voltage is the that voltage, that maximum voltage at which discharge of the ionization of the conductors, air started. Right. We have to derive this critical voltage in order to determine the corona loss and the critical voltage. Simply electric. These are the conductors. Current is going through A and returning from B. There is a space between these conductors A and B is D, and the current is I Q charge at A, and since in conductor B current is returning, net charge will be negative. Now a general point P is taken here, and the electric field intensity E will be simply minus Q upon 2 pi epsilon. E will be simply due to conductor A, E will be Q upon 2 pi epsilon x. Right. Now at point P, the electric field intensity due to the conductor P will be simply minus Q upon 2 pi epsilon naught d minus x. Here x will be simply d minus x, because effective distance from this conductor to this point is d minus x. Because from here, just a second, let me take a spotlight. From this point to this point, this is D, and from center of this conductor A and this point is X, and the distance between point conductor B and P will be simply this D minus X, right? And charge negative because in this conductor B current is returning. Is it clear? Because this is the term, this electric field will go negative because of the current, direction of current is opposite to this reference conductor currents. Right? Since both the fields are in same direction, direction of the current field around the conductor will be same using right hand rule, because the current is outgoing, go into the surface in this conductor A, and in this conductor B current is outgoing, coming outside, due to which direction of the magnetic field of this forefinger will be in both conductor will be same. Okay, I hope that this is clear to you. Hence the total electric field intensity at point P will be simply sum of these fields, right? Field produced by the conductor A and field produced by conductor P. And mathematically it will be equal to the QD upon 2 epsilon naught x T minus x. If you will sum it, you will get these terms, right? Now V dash. What is V dash? The voltage at this midpoint, right? V dash is the voltage on conductor with respect to the neutral plane. Here is the neutral plane. Neutral plane, we can write V dash will be minus d by 2 over ex dx. Why it is minus? I have explained in previous lecture. Okay, why it is minus? And because the unit charge is moved in opposite direction, opposite direction of the electric field intensity, this Ex, right? To T, which it will be minus. And derivation from T by 2 midpoint to radius R of the conductor. Now Ex simply this will be integrated. Here the D will be constant and X upon these are the two terms, 1 by X into 1 by D minus X. This will be simply ln X minus ln T minus X. Or here the limit has been reversed and hence the sign minus sign will be disappeared, right? And after integration we will get ln X minus ln T minus X. We have done this type of derivation in previous lecture also, and after putting the limit you will get the Q upon 2 pi epsilon naught ln T minus R by R, right? This is the final voltage at neutral plane V dash. Now substituting the value of Q upon 2 pi epsilon naught from here, the value of Q upon 2 pi epsilon naught will be simply V dash divided by ln D minus R by R. This one. The value of Q upon 2 pi epsilon naught will be simply V dash divided by this term ln D minus R by R, and you will get Ex will be from equation 14.1 will be Ex will be V dash upon ln D minus R by R into D upon X D minus X, right? In this equation we have put the value of the Q upon 2 pi epsilon naught. Now if the D is very larger than R, means spacing between the conductors is very high in comparison to the radius of the conductor, then D minus R will be simply D, right? And this will be approximated. Ex will be simply V dash upon ln D by R into D upon X D minus X. This D minus R will be simply D. Right. Now you can see that here it is to note that the value of V dash for the single phase line is V by 2. Single phase line it's V by 2, and for three phase lines it will be VL by root 3. Here VL is the line to line voltage. It is clear that the field intensity or the gradient, it's also known as the gradient means change in slope or change in the electric field intensity or electric gradient increases as X decreases. Yes, you can see if the X decreases, here X is directly inversely proportional to Ex. X decreases, it will increase the electric gradients or electric field intensity. Gradient G max will be at X equal to R. X equal to R means surface of the conductor, and this will be equal to E max will be simply V dash. We will put X value of X equal to R, then you will get E max will be simply V dash upon or ln D by R, right? Is that clear? Now the value of the potential gradient at ionization of air takes place under the normal temperature 25 centigrade and pressure 76 centimeter of Hg. पारे के जो 76 सेंटीमीटर होता है जो प्रेशर, वो आपका नॉर्मल प्रेशर होता है एनवायरनमेंट का, और जो 25 डिग्री सेंटीग्रेड टेम्परेचर होता है वो क्या होता है, नॉर्मल टेम्परेचर। तो इस नॉर्मल जो सिचुएशन, नॉर्मल कंडीशन में जो विदाउट जो डिस्चार्ज या आयोनाइजेशन ऑफ द एयर की जो वोल्टेज लिमिट होती है इलेक्ट्रिक फील्ड इंटेंसिटी, वो होती है 30 kVp पर सेंटीमीटर पीक मैक्सिमम लिया जाता है। यही जब आरएमएस की टर्म लेंगे तो 21.1 kV RMS per centimeter and is denoted by G0. This is the breakdown voltage of the air. You have to remember it, right? Putting the value of this breakdown voltage of the air in this V dash this in this equation to determine the voltage voltage at which the breakdown of the air or the ionization of the air will be stopped. This is the V dash equal to RG0 LNT by R. Yeah. V dash RG0 RG0 ln. Here G0 becomes G0 is the simply this one value at this intensity, electric field intensity breakdown started, and it's G0 from this here G max will be G0 and hence V dash will be simply G0 into R ln d by R. This one. You have to remember it. We have to remember this one, very important. Now the dielectric strength of the air at any temperature T centigrade and pressure P centimeter of the Hg पर पारे के 20 सेंटीमीटर प्रेशर पे और 30 सेंटीमीटर पे, मतलब आपका जनरल जो फार्मूला होगा किसी भी टेम्परेचर या किसी भी प्रेशर will be given by G0 delta, where delta is the air density correction. या जो आपका डेल्टा नया टर्म आ गया, ये क्या है? It's dependent on the temperature of the air and pressure of the air, and combinedly it's known as the density correction, air density correction factor. Okay, it's relation of the temperature and pressure with respect to the correction factor is delta equal to d by 76 273 plus 25 upon 273 plus t. You have to remember it. This term, this will be equal to 3.92 p upon 273 plus t, and putting the value of this delta, okay, including the effect of the density factor in this formula, this will become V dash will be R0 delta ln d by R, right? You have to also remember this formula. Now in next formula there will be inclusion of the M. This is the what is M? This is the roughness factor or roughness factor of the conductors. Okay, if the conductor is solid and smooth, okay, it will be equal to breakdown. Normally the stranded conductor are used in the lines and their surfaces are not smooth. स्टैंडर्ड मतलब जो आप मल्टीपल कंडक्टर्स को जब एक कोर पे जो है उसको बैठ देते हैं तो उसको आप स्टैंडर्ड कंडक्टर बोलते हैं। तो उस केस में जो है सरफेस आपका स्मूथ होगा नहीं, तो ब्रेकडाउन वोल्टेज विल बी समवॉट लेस देन द स्मूथ कंडक्टर। स्मूथ कंडक्टर में जो ब्रेकडाउन वोल्टेज है आपका हायर होगा, मतलब हायर होने का मतलब ये हाई वोल्टेज पे ब्रेकडाउन होगा, जबकि स्टैंडर्ड कंडक्टर जब स्मूथ नहीं होगा कंडक्टर तो जो ब्रेकडाउन वोल्टेज होगा वो लोअर होगा, मतलब कम ही वोल्टेज पे ब्रेकडाउन एयर ब्रेकडाउन या कोरोना अपीयर हो जाएगा। ये आपको ध्यान रखना है। Due to irritability of the surface, dust and dirt on its surface, there is a further reduction in the breakdown voltage. अगर डस्ट है या डर्ट है उस कंडक्टर पे तो आपका ब्रेकडाउन वोल्टेज है आपका या the voltage at which corona will be appear will decrease again. Means जल्दी कोरोना पे कमी वोल्टेज पे कोरोना या डिस्चार्ज हो जाएगा एयर। ठीक है, Allowing the surface irregularity of the factor M. Yeah, this is the surface irregularity. M is the surface irregularity of the wire and air density correction factor. The critical disruptive voltage VC will become the RG0 M delta ln dy, right? इससे पहले जो V टेस्ट है, ठीक है, अब ये VC आएगा, critical disruptive voltage. It is the voltage at which complete disruption of the electric occurs. So dielectric. Complete disruption means जो आपका जो भी dielectric है totally ionized हो गया, totally electrons, जिसके जो electrons है rupture होकर के free हो चुके हैं, free to move in the direction of the electric field. Okay, that this critical voltage will be equal to R0 and delta ln dy. You have to remember this formula also. Now, visual critical disruptive voltage, ये जो critical voltage है ये जरूरी नहीं कि आपको विजुअल होगा, मतलब आंखों से देखने के सेम होगा, हो सकता है वो आपको फर्दर आयनाइजेशन नहीं होने की वजह से वो डिसअपियर हो जाए. तो फिजिकल क्रिटिकल डिसअपियर वोल्टेज मीन्स द सस्टेन्ड ionization of the air is known as the voltage at which it appears. It's known as the visual critical disruptive voltage. A critical, its definition at critical disruptive voltage corona occurs, but it's not appear, not visible. The charged ions in air must receive some finite energy to cause further ionization of bipolar. Yeah, there's some finite energy for further ionization or sustained ionization. When the voltage further increases, at some point the corona becomes visible. This voltage called visual critical disruptive voltage VP, and this will be gradient will be given by Gv will be equal to G naught delta 1 plus root 0.3 upon R. You have to remember this formula. There is no there will be no need of derivation of this formula. You have to remember, and very less chance of coming numerical on the basis of this formula. Simply read it and how many factors and which one are more responsible, which are directly proportional, which are inversely proportional for the visual disruptive voltage of the corona or simple disruptive voltage. Now the visual critical disruptive voltage is given by VB or GV MB ln dy. Finally, putting all the known values, that it will be equal to the 21.1 MV or delta 1 plus 0.3 by root or delta ln dy r kb. This is the formula where d and r are in centimeter. These are the distance, or this is our radius, this is the spacing of the conductor. The value of surface factor or roughness factor is MB. MB is the roughness factor and is different from them. Yeah, this is the different M. M was, what is M in previous? And this was irregularity factor M, and this is the roughness factor. And both are different. MV and M are different, right? As conductor surface is irregular and visual corona occurs at the some points of the conductors and is called local corona, right? The surface factor MB is 0.72 for the local corona and 0.82 for general corona. The corona occurs at the some points of the conductor and is called the conductors के किसी पॉइंट्स पे इसके सरफेस पॉइंट पे अगर वर्क ना करता है, दिस इज कॉल्ड द लोको. These are the numericals. You have to, if you remember for all the formula, you can determine by putting the values, given values, or you can determine all the questions or the value will be determined. Right. Now the corona loss, you know, if there is the ionization of the air or the disruption of the air of the dielectric, there will be some loss because some power will be consumed in ionization of the air. Ionized charge near the conductor surface takes energy from the supply system, and thus there is a loss of some energy to the grid. And this loss consumed in the ionization of the air. And this is resistive loss. It is not possible to derive any formula for the exact loss. Yeah, there is no exact formula determined accurately. Several researchers get the empirical. Empirical, you know, empirical is the experiment estimated. It's not accurate. It's determined some almost its empirical formula and is given by the PC equal to 241 into 10 to the power minus 5 into F plus 25 by delta root r by delta VT minus 6. This is the very important formula. You have to remember it. It has come in all the competition. Almost all competition. This is very important formula. You have to remember it and note it down. And highlight it in your notes. Okay. Now you have to, these things are not very important. So you have to know advantage, disadvantage of due to loss. You have read that there is loss, and so you generally estimate that corona is not very good thing, but it's exist and disadvantage in the power system. No, there is also advantage of the corona. You know, there when the high voltage appears, there is the breakdown of the air or ionization there due to which that high voltage effect bypasses in the air. That excess energy ionized air and it's dissipate into there. And disadvantage, there is advantage of this thing. Advantage of corona is that works as a safety wall in the event of high voltage steep wave due to the switching or lightning surges. जब लाइटनिंग और स्विचिंग होता है तो हाई वोल्टेज और सिस्टम के कंडक्टर्स जो है अपीयर होता है, तो उस हाई वोल्टेज की वजह से जो स्टीप वेव आती है, वोल्टेज में जो स्टीपिंग अचानक से कई गुना जो स्टीपिंग होता है, वो आपके जो कंडक्टर्स के अराउंड जो है आपके क्रिटिकल वोल्टेज जो वी डैश अनइक्वलिटी है उसको एक्सीड कर जाते हैं. ठीक है, तो जब वो एक्सीड कर जाएगा तो क्या होगा, उस सडन स्टीप को जो है, जो एनर्जी है, जो एनर्जी होता है उस सडन स्टीप का, जो लाइटनिंग वजह से या स्विचिंग, आपको मालूम है स्विचिंग में जो है वोल्टेज का राइज होता है, तो वोल्टेज राइज होगा तो वो एयर में है ना, एयर को एनालाइज करके अपनी वो एनर्जी डिसिपेट हो जाती है. अगर वो एनर्जी एयर में डिसिपेट होती है तो वो डिसिपेट अगर जो कंपोनेंट्स ऑफ द पावर सिस्टम में किसी होते वो आपको डैमेज कर सकता है. तो ये एक तरह सेफ्टी वॉल्व है कोरोना, बिकॉज द स्ट्रेस प्रोड्यूस्ड डू द स्विचिंग और लाइटनिंग इज पासेज through ionization of the air. That is corona. And this is also, there is also advantage of the corona. And main disadvantage is the corona power loss. We have already read it in the above pages. These are the all over all about the corona, and if there any doubt, you can ask anytime without any hesitation in the group or personally. You have to remember, I am going to revise the main things you have to remember it. This is the first one is the critical voltage. Critical voltage, uh, this V dash R G 0 L and D by R. And second is the visual critical voltage GB. And final, you have to remember this the power loss due to the corona, which factors are involved. You can see here frequency is directly proportional. Okay, delta. Um, we have read it. What was delta? Delta was uh, this one, the air density correction factor. तो ये आपकी इनिशियल प्रोपोर्शनल है Vp minus Vc critical voltage. And what is Vp? Vp is the phase to neutral operating voltage. Right? You have to remember which factor, voltage and frequency and delta are in inputs or have position either directly proportional or inversely proportional. This is very important. There is a lot of questions appear in the many competitive exam like ES and UPPCL, and how frequency affect the corona loss, how voltage affect the corona loss, right? Okay, I hope that each and every terms or the formula explained today is clear to everyone. Okay. Any doubt you can ask freely anytime. Okay. Thank you so much.